The diagram on the right shows an inverted cone with a base radius of 12 centimeters and a height of 20 centimeters. If the height of the waters in the cone is 8 centimeters, we want to show that the volume of the water V cubic centimeter in the cone is equal to this. Okay, so the volume of the water in the cone keep on changing when if the height of the water level increases, then the radius will become longer. If the height of the water level decreases, the radius will become shorter. Okay, now first thing, we know that the volume of the volume of a cone is actually equal to 1 over 3 pi r square height, right? Now you will notice that here we don't have radius, we don't have r, so it means that we need to find a way to represent the r with h. Now here we actually have two similar triangles, one's over here and another one is over here. So we have two similar triangles. So we can use the properties of two similar triangles to help us to express r in terms of h. Now this is 12, this is r. So r over 12, r over 12 is equal to h over 20. Now we know that r is actually equal to h over 20 times 12. So divided by 4, So now we know that h is actually equal to r is equal to 3 over 5 h. So we can replace the r by using the 3 over 5 h. So volume is equal to 1 over 3 pi r squared. So the r, we don't want in r anymore, we want to change the r become h. So 3 over 5 h square the whole thing times h. So 3 square you get 9, 5 square 25, h square. Okay, one more step. So volume is equal to, so this you can simplify them, divided by 3. So eventually you will get 3 over 25 pi h cube. Okay, shown. Now let's look at part B. Water leak out through a small hole at the tip of the cone. So the water is leaking out, so it means that the water level become lower and lower. We want to find small change in the volume of water when the height h decreases from 5 centimeters to 4.99 centimeters. Okay, what we are looking for is small change in the volume of water. It means delta V. And what do we have is delta h. So the h changed from 5 centimeters to 4.99 centimeter. So from here we can get delta h, which is equal to 4.99 minus 5, and you will get negative 0.01. Okay, so we want to find delta V. So we know that dV dH is approximately equal to delta V over delta H. So let's say if we want to find delta V, we can just use dV dH times delta H, right? Now the problem is we don't have dV dH. Do we have delta H? Yes, which is equal to negative 0.01. So what do we need to do now is find the dV dH. So V is equal to this, 3 over 25 pi h cubed. So dV dH will be 3 bring down, multiply by 3 over 25, you will get 9 over 25 pi h squared. Now the next step is to get the value of dV dH. So what the h that we need to use? we need to use the initial value of h, which is equal to 5. So when h is equal to 5, so the dVdh is equal to 9 over 25 pi times 5 squared. Okay, just press your calculator. This is 25, right? So this is 5 squared is 25. 25 and 25 we can simplify them, divided by 25. So eventually you will get dVdh is equal to 9 pi. Now we have the value of 9 dVdh, and we also have the value of delta h, which is given by the questions. So we can get delta v easily. So here actually you want to write equal sign is okay. dVdh is equal to 9 pi. If you don't want to use this sign, you can use equal sign. It's actually acceptable. So time delta h, which is equal to negative 0.01. So no pi is given to us, so I just leave my answer in terms of pi. So delta v will be equal to negative 0.09 pi cubic centimeters. So the small change in the volume is equal to negative 0.09 pi cubic centimeter. It means decreases. Okay, let's look at part 2. For part 2, we need to show that a decrease of p% in the height of the waters will cause a decrease of 3% in its volume. So now, what information do we need? So we want to show that the decrease of p% of the height of the water will cause a decrease of 3p% in its volume. So how do we find the percentage of changes of its volume? Delta v over v times 100, right? So what do we need? We need delta v. So we know that delta v over delta h is approximately equal to dv by dh, right? So do we have v? We just use this one. So we need delta v. So how about delta h? Do we have delta h? Yes. Given by the question, decrease of p%. It means that negative p over 100. Okay, times h. So delta v, you want to write equal is actually okay. So here I will use this symbol, but if you want to write if you want to use equal sign, is okay. So dVdh will be this one, 9 over 25 pi h squared times delta h, and delta h is equal to this given by the question, decrease of p%. So delta v is equal to, so here you will get negative 9p, let me write 9 pi p h cube, and then divided by 2500. This is delta v. What do we need to do next is use this one, just plug in here and show that this whole thing is actually equal to negative 3p. Delta v is equal to this, negative 9 pi ph cube over 2500 divided by the volume, and this is the volume, 3 over 25 pi h cube times 100%. Okay, we want to change to percentage, that's why we multiply by 100. So this one you can change it, become like this, negative 9 pi ph cube over 2500 divided by this, actually equal to multiply by just flip over the numerator and denominator, 25 over 3 pi h cube times 100. So this one, you can simplify them, divided by 25, divided by 25, and 100 and 100 you can simplify further. Okay, how about this? Pi 3 divided by 3 divided by 3 and h cubed. So we go through the whole thing carefully. What do we have? What do we left here? Negative 3p, right? Okay, so we have shown that the a decrease of p% in the height of the water will cause a decrease of 3p% in its volume.